We use them every single day, but we almost never think about them. Today, we're going to pull back the curtain on the invisible genius that's running your computer right now, the operating system. It's this incredibly powerful piece of software that makes everything else possible, but most of the time, we don't even realize it's there.
Okay, so let's just jump right in with a thought experiment. What if you had to use the raw hardware of a computer directly? I mean, no Windows, no Mac OS, nothing. Just pure silicon and electricity. What would that actually be like?
Well, it would be absolute chaos. The hardware is totally unforgiving. One wrong move and the whole system could just crash. It's dangerous, too, because programs could easily stomp all over each other's data. And it's just so inconvenient. It's a million miles away from the stable, safe, and seamless experience the OS gives us, turning all that raw power into something we can actually use. So how does it pull this off? Well, the OS is basically a master illusionist, and it's performing 4 incredible tricks every single millisecond. It creates the illusion of infinite processors, endless memory, perfectly organized storage, and makes all your different hardware components work together seamlessly. So let's break down the magic. First up, let's talk about how a single CPU core can feel like it's running dozens of programs all at once. I mean, think about it. You've got your web browser, a music player, your email client, all running smoothly. This is the art of juggling the processor's time, creating the illusion that every single program has the CPU all to itself. Now, to manage all these tasks, the OS uses 2 main concepts, processes and threads. And there's a really great way to think about this. A process is like an entire company. It's got its own secure building, its own supplies, everything. A thread, on the other hand, is like a single department inside that company. It shares all the main resources, which makes it way lighter and faster to manage. So the simplest way for the OS to handle these tasks is just first come, first served, kind of like a line at the grocery store. But this leads to a huge problem. If a really long, slow task gets in line first, all the quick, easy little tasks get stuck waiting behind it. This traffic jam has a name. It's called the convoy effect. But of course, the OS is way smarter than that. By using a method called shortest job first, which basically lets the quickest tasks cut in line, the performance gain is massive. Look at this. The average wait time just plummets from a sluggish 17 milliseconds all the way down to a snappy 3. That is the difference between a system that feels responsive and one that's just frustrating to use. All right, on to the next great illusion, infinite memory. How in the world can a computer with, say, 16 gigabytes of physical RAM run programs that need way more memory than that? I mean, that seems impossible, right? The secret is this amazing trick called virtual memory. What the OS does is give every single program its own private, imaginary memory space. Then, when the real RAM starts to get full, the OS just cleverly moves the least used chunks of data onto your much larger hard drive, freeing up that precious RAM for whatever is active right now. So, and this is the crucial point, this isn't just about having more space. It's about intelligent management. The OS is constantly playing this high-speed shell game with your data, making sure every program has the memory it needs exactly when it needs it without ever letting them interfere with each other. And this idea of intelligent management extends to our files too. This brings us to the third illusion, infinite organized storage. You see, your hard drive is really just a massive, unorganized mess of data blocks. The OS's file system is like a master librarian that gives it all structure, turning all that chaos into the neat files and folders that we all recognize. At the very heart of this system is a tiny but incredibly mighty data structure called an inode. Every single file on your computer has one of these. Think of the inode as the file's DNA. It holds all the important info, like who owns it, its permissions, when it was created, and most importantly, it holds the addresses for where all the actual data blocks are stored on the disk. And check this out. The way it does this is just brilliant. For a small file, the inode points directly to the data blocks. But for a huge file, it uses this really clever trick. It has pointers that point to lists of other pointers. This creates this branching structure that can just keep expanding to handle gigantic files, all managed from one tiny little starting point. So what does all that cleverness actually get you? Well, with this structure, a single inode can keep track of a file that's around 4 terabytes in size. That is one massive file, all managed by one tiny, incredibly efficient data structure. Of course, there's more than one way to organize all this data. You've probably seen these names before.
FAT32, for example, is simple and universal, which is why it's on most USB drives that you might need to plug into any computer. Then you've got modern systems like Apple's APFS, which is built for the incredible speed of solid-state drives. Each one is just a different set of trade-offs between compatibility, speed, and fancy features.
So, you have juggling the processor, bending the rules of memory, organizing storage. These aren't just separate tricks happening in isolation. The real magic is how the OS weaves them all together, constantly, to create one single, cohesive experience for you.
They all combine to form one grand, seamless illusion. The OS is like the conductor of this incredibly complex symphony of hardware. It's making sure the CPU, the memory, the storage, and all your devices work in perfect harmony. And it creates an experience that's so smooth, we completely forget about the billions of operations happening underneath it all.
And that's really the big takeaway here. This invisible layer of software is the absolute foundation of everything we do on a computer. It's the reason our machines are stable, the reason they're safe, and the reason they're powerful enough to run all the applications that define our digital world.
And all this leaves us with a final, really interesting question that OS designers wrestle with every single day. When you delete a file, most systems don't actually erase the data. They just mark the space as available for something new. Why? Because it's fast. Actually scrubbing the data clean takes time and slows things down. So what's more important, pure system performance or users' absolute privacy? It's a fundamental trade-off, right at the very heart of the operating system.